Good morning. First of all, I would like to thank you for attending this presentation. The project we are talking about today is the design of the suspension for our upcoming model year vehicle. I have shown just one corner suspension setup, which just consists of the shock absorber, which would act as a damper, and the spring, and then the mass of the system would be this corner of the car. The system can also be represented as a free body diagram similar to this one. The response equation of the system is found to be this, where M represents the mass, C represents the damping constant, and K represents the stiffness of the spring. The figure also shows the displacement, velocity, acceleration, and force functions. To simplify the calculations, I have replaced the mass, damping constant, and spring stiffness of our suspension with slightly friendlier values just to make sure that the calculations were done correctly. However, upon checking my calculations are correct, these values can easily be replaced with the correct values, and the calculations can be done in no time. So like I was saying, I replaced the mass with a value of 1 kilogram, the damping constant with the value of 2 Newton seconds per meter, and the spring stiffness with the value of 5 Newton meters. Using this, I calculated the values of the natural frequency, damping ratio, peak time, rise time, and many others, which are not shown here, and was able to identify that this particular system was underdamped as the damping ratio was 0.447. I then performed the same calculation using 3 different methods to ensure that my calculations were correct, solving the second order response function using the classical ODE approach, the Laplace approach, and MATLAB. The actual work used to perform these calculations can be found in the report that I have previously submitted. I found that my solution was consistent and that each resulted in this equation. I plotted the equations from both of my hand calculations, and both response graphs turned out to be identical. As such, I know that my calculations are indeed correct. In retrospect, I realized that the MATLAB code that I have written for this project is slightly longer than was necessary, and if asked to make it more efficient, I would simply utilize the dsolve function, and I've been told by my colleagues that it shortens the code exponentially, and as such, we'll try it for the next project. So now that we know that the calculations were performed correctly, there is one more piece of information that we need to clarify before putting in our own values and recalculating. That is, there are 2 scenarios to consider when determining how to tune the suspension, and it varies vastly based on the type of ride that we aim to supply to our customers. We will need to decide whether we want our vehicle to have softer suspension or stiffer suspension. I will detail both options so that we can make an informed decision. Let's start with what's known as a soft suspension setup. This is the kind of setup that you would generally find in more luxurious vehicles. In a softer suspension, the damper of the system would take longer to dissipate the energy of impact, but the spring would take longer to compress, so the cabin of the vehicle wouldn't receive a very large jolt upon impact. A vehicle with a system like this would take a long time to reach steady state. In a firm suspension setup, on the other hand, the damper of the system would try to dissipate the energy of the impact very quickly, and the spring, which would have a very high spring constant, would also react very quickly. Stiff suspension setups are generally found in performance vehicles as they generally give drivers a more accurate feeling of the road surface. This type of vehicle would reach steady state very quickly. As our customers' comfort should be our top priority, my recommendation is that we use a softer suspension setup. Despite it taking slightly longer for the system as a whole to reach steady state, I feel that this is the better option. If you have some time, this link leads to a video of a clear motion suspension project that essentially uses audio waves to deliver a very smooth ride for passengers, and it is a very interesting watch. Thank you.